If the Van Allen belts are super hot, why didn't the astronauts burn up? They say there's no way we could have gone to the moon because of that. But is that true? All right, so let's check the math. I came across this video by Carlton Music on Facebook. Let's see what he has to say.
Someone once told me that the moon landing never happened, and I looked at him like he was a tinfoil hat nutter and told him to...
Okay, I'm definitely using that word nutter in the future. I like it.
Get out, and told him to stop spitting on the greatest human accomplishment of all time.
That's really good advice.
And then he asked me, well, Reese, right, how did they get through the Van Allen belt? And I didn't know what that was.
Good
and
question.
He told me what it was. Radiation and also heat that surrounds the Earth. That...
He's close. The Van Allen belts, there are actually two of them, don't surround the Earth. Well, not completely. They are donut-shaped rings of highly energetic charged particles. They're trapped in the Earth's magnetosphere by its magnetic field. They were discovered in 1958 by astrophysicist James Van Allen. I mean, what are the chances somebody would discover something like that shares their name? What? Oh, wait, never mind.
What an idiot! Oh, what a loser!
The Van Allen belts actually protect the Earth, but they can be dangerous. However, it was Van Allen himself that calculated that it was possible for astronauts or spaceships to fly through the weaker regions of the radiation. That's why Apollo and Artemis both had trajectory angles that were designed to pass through at a specific angle instead of going straight through, and a high velocity that would minimize exposure. So let's see what else he's got to say.
At its hottest is 20,000 Kelvin, and its coldest is 2,000 Kelvin. And then...
Yeah, he's correct. It is really hot. He's still not wrong. Something is not adding up, though, because he and his friend aren't doing the math, so I will. He's been talking about heat, not radiation, so we will too. I'll cover the Van Allen belt radiation in a future video. So heat is transferred in three different ways: radiation, convection, and conduction. Radiation is when energy is transferred directly through space in the form of electromagnetic waves. Think about sunlight. So this won't transfer heat from the Van Allen belt to any spaceship. Second way is convection. This is when heat is transferred by physical movement of a liquid or gas. No liquids or gases are out there, so this isn't it either. Finally, we have conduction. This is when heat moves through solid objects or by touching objects. This is what is happening in the Van Allen belt. But wait, why isn't this guy right? Why don't spacecrafts melt? Well, it's actually quite simple. The Van Allen belt is indeed hot. It's really hot. But it's also a near vacuum. There's almost nothing there to transfer that heat. There's just not enough atoms, not enough physical atoms in the Van Allen belt to transfer enough heat to cause any substantial damage, especially over the short amount of time that they're actually there. It's just physics. We'll let him continue.
Then he said to me, how long do you think it takes for the aluminium shuttle, which melts at 900 Kelvin, to get through the Van Allen belt? And I said, well, it must go really quickly. It must be like, I don't know, 5 minutes or 10 minutes. So it must be like I don't know, maybe it's... He said it takes 50 minutes. And I was like, wow, okay. So they must have some protective shield around it or something. Maybe it wasn't made out of aluminium. And then he said, yeah, well, think about the fact that they've got to come back through the Van Allen belt as well.
Yep.
So they've got to spend, give or take, an hour and 40 minutes in radiation that at its coldest is 2,000 Kelvin and hottest is 20,000 Kelvin. And I was like, hold on a minute. Something's not adding up here.
He goes on to talk about other reasons to doubt the moon landing, such as various pictures and the boot prints not matching the boots. We'll get into all of that stuff in a future video. And like I said earlier in the video, I'll discuss the radiation portion of the Van Allen belt in a future video. So thanks for watching. If you have any comments, please leave them below. If you have any suggestions for future videos, or if you disagree with anything I've said, comment below and we'll talk about it. So please check out this video right there. It's another good one with some cool science. And as always, thank you very much.